Hey everybody, great to be here for this webinar, IoT end-to-end integration with Confluent Cloud. This is a webinar, but actually we want to make it more interactive today. So we will use a whiteboard to explain the architecture and the different technology components. And also we will do a little bit of discussion together. So my name is Waehner. I work as technology evangelist for Confluent. And I'm here today with a real expert about IoT. So hi Konstantine, welcome to the show.
Hey Waehner, welcome back as well. I'm Konstantine Karantasis, software engineer here at Confluent and working in Kafka Connect team. That has given me the opportunity to also do some work with IoT and MQTT.
Yeah, so you're perfect for the session here today, and I'm looking forward to discuss with you because I will cover a little bit the use cases behind IoT we see with our customers, and then we will talk about the architecture and the different technology components which we provide from Confluent, and that is also where Konstantin will come in a few minutes again, and then we will also talk about how to do this really end-to-end and think about processing of the data in the cloud, and then also sending data back to the edge for the IoT processing. And we will conclude this session a little bit with the vision about how it will continue in the next few months and years around Kafka and Confluent. So with that, thank you, Konstantin. See you back in a few minutes.
Yeah, see you soon.
Thank you. And I will start with talking a little bit about the use cases. So Internet of Things, I mean, it's a buzzword for a long time already, but now let's really talk about use cases we see at our customers already. So the first big example is connected car infrastructures. And connected cars is a really good example, and you can think about that also for monitoring trucks, for example, or many other things. And it's really about real-time tracking and integrating different things. The point is not just ingesting all the data to Confluent Cloud for processing the data, but also calculating things, processing things, and sending data back to the cars. For example, for predictive maintenance in real time or near real time, for cross-selling, for many other use cases which you can think about. That's, for example, Audi is doing that a lot. Another example is energy distribution. Energy is a huge topic, and it's really changing how it's working today. And for example, E.ON is doing that. Every house can produce energy in the future with many different technologies, and then you can sell it to your neighbor or to some other people. And so you need a really big provider which collects the different information, and then you can combine all of this information together with others. Another third use case is Customer 360. Customer 360, first of all, you think about things like customer relationship management, but it's also about many devices like mobile apps, for example, where millions of devices are used and you communicate with each other and integrate it with other information. You correlate the information and then also send information back to the users. And the fourth example is manufacturing. So here it's really more about smart manufacturing. So what you want to do is that you process the data, for example, in factories or in the assembly line. So you continuously integrate and analyze sensor information. You get all the data from the devices, you put it into the cloud for the processing, for doing analytics, and then also for sending information back. Or in some cases, you just process it locally at the edge, where you want to do some things like throwing away parts to reduce costs in this assembly line and all these things. That's some different use cases I want to talk about, and we see a lot more in many different industries. And now really let's talk about the architecture for this. So there is many different components which are relevant here. First of all, of course, we start with the things. I mean, that's clear. This is the topic of today's talk. And things can be anything. In a connected car infrastructure, it's the cars, of course. But it can be also MES systems in manufacturing. It can be mobile apps for retailing. It can be more or less anything, but typically it's a lot of different devices and they produce a lot of data continuously. It also can be many different technologies. It might be some standard-based stuff like JSON messages, or it might be OPC-UA standard, a lot used in manufacturing, for example. Or maybe it's even some proprietary technologies which you need to integrate. And this data is continuously produced from these kind of sensors in IoT. And then often you also have a gateway in the middle. So a gateway is used because you don't want to connect every single device to the cloud, but leverage a gateway in the middle where the data is sent to. This gateway typically also has some kind of storage. So here you can store data, and then from that you're moving the data to the cloud. So this means you send all the data here and it's going somewhere else, and in this case to a streaming platform. The streaming platform is here to store all the data when you ingest it here, and then you process it with that platform. So let's make it right. So this is the streaming platform. This is the big thing, which is really scalable and processes a lot of data. So typically it does not just integrate with one of these gateways, but with several ones, typically in different regions or in different factories, depending what your use case is. This also, of course, has storage so that you can store the data here either for some days or some weeks or even forever, depending on the use case. And then as next step, of course, you want to also use the data here. So for example, you want to build some real-time applications here. This could be something like fraud detection, for example. So you send the data here, and then of course you also send data back all the way to the devices. This is very important because you want to not just ingest the data and process it, you want to send data back. And depending on your use case, this could be real-time. In other examples, it's more about things like near real-time. This means it can take some seconds or maybe even some minutes, depending on how you define real-time. And in many other cases, even batch is fine. So you ingest a lot of data into another big data system where you process it maybe for some days, and then you get some results for reporting or some analytic models which you deploy somewhere else. There's a lot of different use cases, and the important thing really here is, so in the end we have the separation here between edge, which we have on the left side in this picture. This is where the IoT devices are and typically some gateways. And on the other side we have the cloud, which is much more scalable and flexible because you can scale it up at the big cloud hyperscalers and so on. This is the basic architecture which we are talking about, and the question is really how can you integrate this now end-to-end from the things to the end application which are running in the cloud, but also send data back to the things afterwards. It's really about end-to-end and continuously processing the data at high scalability without downtime and without data loss. That's the architecture which we need to think about. And now let's think a little bit more about technology, because that's now important here. How do you realize this? So of course, in the end, you have some kind of IoT technology. This could be something like a standard like MQTT, which you use as interface to produce events. And therefore, of course, in this case, then you also have an MQTT broker, which consumes the data from the devices and stores it and forwards it somehow to the streaming platform, which is, of course, you might have guessed that, this is Apache Kafka in the middle. This is more or less the de facto standard for event streaming platforms. So here we have Kafka, we get all the data ingested from the IoT devices, and that's the main goal. But the question is, how can we do that? There are many different options how you can do that, and let's talk about that. So the first obvious option is, of course, you use Kafka Connect. Kafka Connect is part of the Apache Kafka framework, right? So when you download Apache Kafka from the website, Kafka Connect is already in there. And then you can use connectors. And one of Confluent's connectors are the MQTT connectors. And with them, you can either consume data from the MQTT broker and then forward it to the Kafka cluster in the cloud. Or on the other side, it's the other way around. So you consume data back from Kafka and push it into the MQTT gateways and devices. This is really important for end-to-end integration. It's typically bidirectional. Just ingesting data into the cloud is one thing, but when you have your other applications in the cloud, you want to send information back to the things. Again, the common use cases are things like predictive maintenance, cross-selling, or all these kind of things you want to do. So Kafka Connect is a very obvious option, and it's pretty cool because it scales well. It leverages all the features from Kafka under the hood. However, on the other side, there's other options. You could, for example, use an MQTT proxy from Confluent instead. The Confluent proxy is used to really also forwarding the information from the devices directly to Confluent Cloud. In this way, you don't need the MQTT broker anymore. And Konstantine in a minute will talk a little bit more about that in detail. This is another option you have. So you can directly integrate with the IoT technologies. In this example, via MQTT standard. But there are other options. In some cases, you have pretty big factories, for example, so you want to deploy more there to be more highly available even in the factories. In this case, you set up your own Kafka cluster in the factory, right? And here you have the data and connect it directly here and speak to the things from the factory, like from the assembly lines if they have sensors. And then from here you send the data over the network to Confluent Cloud via the Replicator, which is another product from Confluent, where you can, in a reliable way, integrate different Kafka clusters with each other. There's many deployment options, for example, just in one direction or even active-active, depending on your use case. And it's also leveraging Kafka Connect and all of its features under the hood. Another option, besides doing that, is, of course, when you use these Kafka clients, which can be anything like Java, like Python, like Go, right? Or also something like the REST proxy from Confluent. With these kind of clients, you also have different options. So you can either send data to local Kafka clusters, like in the factory, or you directly send it over the cloud to Kafka. So there's different options. Let's discuss that with Konstantine also. It's not really trivial to decide what's the best option. So this is the different options you have. There's plenty of options of how to integrate Confluent Cloud together with the IoT sources. And now I want to talk a little bit more deep dive about that with Konstantine to discuss the different trade-offs and options what you want to do. So Konstantine, welcome back to the show. Here you
Hi again,
are.
Kai.
Hey, Konstantine, great to be back. So let's talk a little bit more about this architecture, which we see a lot at our customers. The first thing about this is, well, I mean, this is now integration with some different interfaces, right? And the point is, what's so specific challenges about IoT integration? What's different from integration with a relational database, for example?
Yeah, great question. Well, IoT poses some specific challenges. It has to do with how devices operate and how they are working on over the network. So IoT, first of all, in IoT, we can't assume that the network is stable and very reliable. You have intermittent connections, devices go on and off at different times, unpredictable times. They come back online and they might produce data that will arrive as late data in our infrastructure. And also you will have to deal with duplicates potentially, both in the protocol maybe, or even downstream when you consume the data produced by the devices. So these are a few of the challenges. As well, you have probably small payloads, small packets produced by the devices, but at the same time, you definitely have to do with a huge number of devices, and therefore large number of connections.
That makes sense because, for example, with connected cars, of course, there's millions of cars and not just tens of cars or something like this. So that's all the challenges you explained. So it's very different to integrate with IoT specific devices. And now let's talk a little bit more about how can you solve these challenges. I mean, you see, I already discussed a little bit the different options you have from a Kafka perspective, how to integrate these IoT technologies together with Confluent Cloud to bring the data in the cloud and to process it more. So can you talk a little bit about the different options we see here, like the MQTT Proxy versus the MQTT broker, and what are the trade-offs of these? So mainly focusing really on Kafka Connect and MQTT Proxy, and what's the trade-offs of that?
Yeah, these are all different alternatives that are at your availability. So MQTT, first of all, it's a popular protocol for IoT and devices to communicate. So based on that, you might have already in your deployment MQTT brokers. So if you want to keep this architecture and maintain it, then the Kafka Connect MQTT connector is a great fit. Fits very well into this architecture and will play well with the existing MQTT brokers that you will have. It will be able to import and export data in both directions with Kafka. Now, if you now don't want to maintain an MQTT broker, if that adds redundancy to your architecture, you may choose to use Confluent's MQTT Proxy directly. This is another scalable way that will allow you to import data from devices to Kafka for later processing. Now, of course, at this moment, MQTT Proxy supports only publishing, and it doesn't offer end-to-end bidirectional publish and subscribe with MQTT protocol. However, your data, once in Kafka, they are available to different applications.
Yeah, and hopefully we also will get soon the other bidirectional way. That's another point, of course, which we want to implement, because then it's also another option. And what I've seen a lot at customers is it's really MQTT broker, if you need it for other reasons also, it makes a lot of sense, but in some cases it's really just additional cost and efforts for running that, because you have one more component. And the MQTT proxy, I think it can really simplify your complete architecture if the main reason is to integrate the different devices into the Confluent Cloud. So that's a great point. Let's talk a little bit more about Kafka Connect before we go to the next component. We, for example, have an MQTT connector which is in both directions, as source and think. Many of our customers have other technologies like OPC-UA and their implementations. So can you talk a little bit about how to build another connector? Because I mean, you have built, I think, most of the MQTT connector part. So if customers have specific requirements where there is no connector available today, you can build them, right?
Yeah, the connector can be built easily. Actually, once this connector implementation is available, you can deploy it to the same infrastructure that you have already running, which is the cluster of Connect workers. You can have multi-tenancy there, lots of connectors running, different types of connectors, and of course they can be sourcing or syncing data from the same cluster. There's no restriction there. And now, once you have the connectors, of course, the connector implementations, it's a matter of configuration mainly, to configure them to import to the specific topics, and some amount of tuning sometimes is required. But once you have the source code, basically you pick the connectors that will address your requirements, and you deploy them in the Connect cluster.
Yeah, that brings me to another great point, because you mentioned that Kafka Connect, it's also based on Kafka producers and consumers, so you can easily scale that up and down to more and more instances. And then you can, as Konstantin explained, either you run a different cluster for each connector or more connectors in one cluster. So that's up how you want to design it and how your architecture is. But you can also start small and scale this up more and more, either to one specific technology with more throughput, or even to different technologies with just one Kafka Connect cluster if you want that. So that's great, and that's what most people think about first. But now let's think about another option, which some people think is not that obvious, but we see that in the field a lot. And that's specifically really the REST proxy, because I've seen a few customers in the field which said, no, I just use HTTP and HTTPS to communicate between IoT and Kafka. Can you talk about that a little bit more? Does it make sense at all, and when is it sufficient?
Yeah, it makes sense, especially if HTTP is a strong requirement by your architecture because of your network architecture, firewalls, or even the protocol that your clients are using. This is very common. So it will fit better if the volume of your data is lower, and of course stateless over HTTP. Now, your clients, in that case, they can communicate, they can contact REST proxy in the middle between clients and the Kafka. And this support is also bidirectional, so it can allow you to publish and subscribe to topics that will publish IoT data to Kafka.
Yeah, that makes sense. And I've really seen many customers where they said in some of their factories they don't produce much messages which they want to send to a Kafka cluster. Maybe if you think about 5,000 per second or 10,000 per second, that's pretty easy to do with one or two REST proxies. So it's relatively easily. Only if you really have to produce millions of messages per second, then it's much more critical, and probably HTTP is not the right technology anymore. But it always makes sense to evaluate that from the beginning also. And the same is of course true if you want to build your own application like with Java or Python. Think about that architecture. Does it make sense to connect it directly, like you see here, to the cloud infrastructure, to Confluent Cloud, or spin up an on-premise cluster? That's also fine, and depends really on the architecture and your need, not just today, but also think about the future. How do you have to scale this up regarding the communication between cloud and the on-premise environments? So with that, Konstantin, let's talk about the last important point. So you also said that our MQTT proxy today doesn't support bidirectional communication. This is a feature which we will implement hopefully this year, but it's very important for many use cases. Today you can only do it with Kafka Connect with our solution. let's talk a little bit about what's the challenge here. Why is it so much more difficult to introduce bidirectional communication? And on the other side, the REST proxy can also do that, right? So I think it's also possible for the MQTT proxy to implement it.
Yeah, it's definitely possible. As we hinted a little bit at the start, the main challenge, the objective that we want to address is support a really high number of connections. And there is a certain amount of consolidation or aggregation of clients to specific instances of the proxy that you want to support. So in this case, of course, consuming or subscribing to topics in order to read data that might have been published a little bit earlier or just a moment ago, it's a little bit more challenging because it's more stateful operation than just producing. So you will have to do some filtering, you will have to do some processing of messages in order to extract the messages that definitely match your subscription. So a little bit more challenging and more stateful operation, but definitely possible.
Oh, cool. So that sounds also good for future releases, so that we bring in exciting new product features into our Confluent platform. So Konstantin, thank you a lot for joining here. This was a great discussion. See you next time in the next webinar or so. And I will now cover a little bit more the processing and storage of data. Thanks a lot.
Kai.
Thank you. Okay, this was a great discussion with Konstantin about the IoT integration. So the next important point, of course, is in an end-to-end integration scenario. It's not just about sending data from A to B, like from the device to the cloud and back, but really also about building applications and processing the data. So that means, for example, if you send the data to a Kafka topic from IoT devices, why do you want to directly send it somewhere else and process it there if you natively can leverage Kafka for that? So a part of Apache Kafka is Kafka Streams. So it's part of the Apache project. You can use that for continuously processing data and then sending it back to another Kafka topic, and from here you can get it to another application, which could be another Kafka Streams application, or maybe a real-time application which you build with Java, Python, or whatever. Or it can be the Elasticsearch consumer or the batch processing, right? So here you can have things like maybe a Java application, maybe something like Elastic, or maybe something like Spark here for batch processing. You can always decide, but you can natively process the data continuously with Kafka, either with Kafka Streams, or what also Confluent offers as part of its community is KSQL, where you just have to write KSQL queries, but these queries can be deployed for continuous processing of data, and they scale like Kafka and Kafka Streams to millions of messages per second. And so then why not leverage Kafka natively instead of building another big data cluster? That's what you always have to think about when building this kind of architecture. It's just an option. Pick what you need. That is what I highly recommend. So that is really then the whole architecture which you have to think about. Integrating the data and processing the data. Where do you want to do it? At the edge, in the cloud, and how do you combine these two and do the bidirectional communication with that? As last part, I now talked a lot about cloud and Confluent Cloud and Kafka. The important part here is, of course, that either you can run Kafka by yourself in the cloud, either by spinning up like an EC2 instance on AWS, or maybe by using a Kubernetes cluster, or if you don't want to manage that by yourself, you can also use Confluent Cloud. So Confluent Cloud is based on Apache Kafka, always on the newest version, and it has a lot of huge benefits for you. So one of the benefits is, of course, that it's managed for you, so you don't have to do that, you just use the APIs. But even more important, we provide SLAs for you with that. So that means you get an uptime guarantee and also a throughput guarantee. So if you say to us you need 100 megabyte throughput per second, then you get it from us, right? And we scale it for you. You just write your implementation of the clients, like the producers and the consumers, which can be anything. Java, Elastic, Spark, MQTT. That's what you decide by yourself. So that's huge benefits, and then you can grow as you go with that. That's also, you start small with a first sensor use case, and then when you add more sensors, you can scale up the cloud. The operation might get more and more difficult, but you don't have to care because it's a managed service provided by the experts of Apache Kafka. And also the next point is, of course, it's also huge because this is also possible with multi-cloud and hybrid architectures. So there's many different deployment architectures which you have to think about in an IoT scenario. Do you want to deploy a Kafka just in one cloud, in one hyperscaler like AWS, maybe in different regions, maybe multi-cloud on Google and on Amazon, or maybe hybrid, so you deploy your Kafka cluster on-premise and in the cloud. Or maybe you spin up one Kafka cluster over different regions. So all these things are possible, and you have to think about different challenges of that, where we can help you discussing this. You see, we don't have just the IoT experts, but also several cloud experts and other subject matter experts on the different topics. So that's in the end also important to understand. And with this architecture, I just want to finish up with one last point, and that is talking a little bit about the vision here. Because all we have seen here today, that's already possible to realize, and there's a lot of components where we can support you with, in addition to the Kafka teaser, the expertise around Apache Kafka. So 3 more things which we want to talk a little bit about the vision, which we see in the future, and it's very relevant for IoT scenarios. So the first vision we have is really to be global. That means that you can spin up Kafka clusters everywhere over different regions with region awareness and all these kind of things. For example, a new Kafka improvement proposal is implemented these days so that you can consume or fetch data from the follower, not only from the leader. This is one example of a big game changer to make Kafka more global. Another vision we have is to be infinite. So that means that you don't have to think that much anymore about how many partitions do I need, and it cannot be more than, I don't know, today 200,000, next year maybe 1 million. I want to have infinite partitions so that I can scale up as much as I need without thinking too much about that. And also solve a little bit more the issues about rebalancing the data. That's all hard things today. And with that, it should also be more elastic, because today in Kafka it's really hard to add new brokers. You have to move partitions by yourself and scale it up, and scaling down is even harder afterwards, and also it takes a lot of time if you have a lot of data. And this should be much more elastic so that you can add new brokers very easily and also stop brokers easily. So when we think about Confluent Cloud, for example, it's more like consumption-based usage where you really pay for what you use. And if you don't use it at all for a moment, then you don't pay for that. And that's only possible if Kafka is more elastic, so that we can more or less shut it down to almost zero cost. And that's more or less the vision. And with that, I want to finish this up. I thank you a lot for watching this. And the important message for the end, please give us feedback for that. So this is a different kind of webinar here. It's more interactive with whiteboard and with different people discussing. Let us know if you liked that and if you want to see more of that. And now with that, we are also going over to questions. So now please let us know if you have any technical questions about what we discussed today. And we will answer it now after the session here. Thank you. Goodbye.